Hello dear students, welcome to the second video lectures on structural design 1s. I am Dr. Samadhan G. Murkade, Assistant Professor, Civil Engineering Department, VPKBIT, Baramati. In first video lectures, we have discussed the detailed syllabus of this subject, structural design 1s, teaching scheme, examination schemes, applications of steel structures, and what are the prerequisites required to understand the basics of structural design 1. Okay, now in this second video lectures, I am going to discuss about the introduction to various design methods. To design the structures, various different methods are available. So what are the different methods that we are going to discuss? Okay, so just start about the discussions. Okay, now what are the steel structures? In steel structures, structural steel is the main load carrying material to transport the load within them and to transfer load to the grounds. Okay. So examples are the I-beams, T-section, channel sections, steel plate, etc. These are the various components of components from which steel structures have been made. Okay, and load has been transferred from to element to element to the grounds. Okay, then next is steel concrete composite structures are also used in high-rise building, but we are only going to study about steel structure in this course. Okay, so composite structures are also there, that is steel and concrete means beams and columns are made up from steel, and slab is of RCC. That structure is called as composite structures. Okay, but that is not in our syllabus of SD1. Now the common steel structures. Okay, roof truss in factories, cinema hall, railways, etc. Then crane girders, columns, beams. In the industrial building, there are crane girders are there to transfer the goods and machineries from one end to another end. Crane girders are there. Then plate girders in bridges. Yeah, when single rolls, when roll sections are not sufficient, in that case we have to go for the deeper beam, and that deep beam is called as a plate girders. Okay. Then transmission tower, water tanks, chimneys. Okay, these are the special structures. Okay, that is not in our syllabus, that you are going to discuss in your MTech structural engineering, that advanced design of steel structures. Okay, this is the photograph showing the frame type steel buildings, that columns beams are made up from steel, and normally if it's a slab is in RCC, then such structure is called as a composite structures. Okay, this is the industrial buildings. This is the aim of this our course, is we are able to analyze and design such industrial building at the end of this course. Okay, this is the column, then this is the truss. It is a beam type truss. Okay, in conventional truss is something different. Okay, and this is the, then these are the purlins. The sheets comes into picture. Then the side sheetings. Okay, then the column is resting on base plate and all this. Okay, this is the applications of steel structure. Truss bridge, then suspension bridge. Okay. Now coming to advantages and disadvantages of steel as a materials. Okay, advantages: steel is having a high compressive and tensile strength per unit weight, hence low construction weight and save space. Small sections will be required compared to the others. Okay, so like we know that concrete is very good in compression, but it is very weak in tension. But such thing should not be in case of steel. Steel is having very good in tension as well as compression. Then good aesthetic view, good quality and durability, very high speed of construction, reusability and scrap value, environment friendly. Scrap value is very high for steel, whereas for concrete it is almost nil or in negative also. Better solution to cover large span and tall structures. Disadvantages: high initial cost, it is corrosion. Steel is susceptible to corrosion if it open to atmospheres. Low fire resistance. To avoid the corrosion, we have to give some special anti-corrosive treatment to our steel structures. The properties of steels. These are the physical properties given in IS 800-2007 clause 2.2.4. Density. Density of steel is 7850 kg per meter cube. or 78.5 kN per meter cube. Modulus of elasticity E is equal to 2 into 10 to the power 5 Newton per m square. Then Poisson's ratio mu is equal to 0.3. G is equal to 0.769 into 10 to the power 5 Newton per m square. Coefficient of thermal expansion 12 into 10 to the power minus 6. Okay, these are the physical property. You must, these are already given in the code, but you remember this property, because what happened, most of you have to appear at the end, you have to appear for the oral examination also. Most of the times external examiner may ask the questions, what are the basic physical properties of the steel, and in that case you must be able to answer these basic questions, because you all study all the syllabus, and if you don't know the physical properties of the steel, then what is the use of doing such learnings. Okay, so please keep in mind, remember this physical properties of the steels. This is the mechanical properties. These are given in the table 1 of IS 800. Structural steel, highest tensile structural steels. This is the designation FE 410 ABC. Three categories are there. FE stands for iron. This is 410 indicates its UTS, that is the ultimate tensile strength in Newton per meter square, and yield strength normally is 250. Okay, so if while solving the numerical it is given in E250 or 410, in that case you have to take UTS, ultimate tensile strength, as 410 and yield strength as 250 MPa. Again it depends upon the thickness. Okay, but normally in our section thickness is less than 20, so we are generally taking 250 as a yield stress. Then ductility, ability of a material to change its shape without fractures, that we call as the ductility. Means material can be drawn into wires. For mild steel is very high ductile material because carbon percentage is less, whereas for high strength steel or high carbon steel, ductility is low. As long as carbon percentage increases, ductility decreases and strain increases. Then toughness and brittle fracture, ability of a material to resist or absorb impact like earthquake load, machine load, etc. Requires both strength and ductility. At low temperature, steel fails on impact loading due to reduction in ductility and toughness, called brittle fracture. Temperature, at a high temperature, strength reduces. Then corrosion. Steel corrodes in moist air, seawater and acid. Adopt painting, metallic coating, plastic coating using corrosion resistant steel to resist corrosion. Then hardness, resistance of the material to indentation and scratching. To determine the hardness, Brindle hardness test, Rockwell hardness test number are used to measure the hardness. This test already we are performing the strength of material. Then fatigue, damage of material to cyclic loadings. When cyclic loading is occurred normally in the moving load and earthquake or vibration, that phenomenon is called as a fatigue failure. Then the residual stresses. When steel has been manufactured in industry, it is subjected to very high temperature, means almost more than 1000 degrees centigrade, and when it is set, that section when it comes to the atmospheric temperature. Okay, so there is a lot of temperature difference, and due to this temperature difference, that stresses has been locked in these sections, and that stresses are called as residual stresses. The stress concentration, under loading, stress is concentrated at place at abrupt change in the geometry, like hole. When there is a reduction in the cross section area, there is a possibility of stress concentration. The stress concentration occur at that point. Then steel sections, various types of steel sections we are going to use in steel structures. They are I section, T section, channel section, angle section, steel bar, tubes, plates, etc. Okay. And the properties of these all sections have been given in the steel table books. See, these are the common steel sections: T section, angle section, hollow square section, wide flange I section, I beam, channel sections. Then built-up sections. Sometimes single section is not sufficient. When load is high on your member, in that case we have to go for the built-up sections. With roll steel sections, see, I-beam has been designated like this: ISGB, Indian Standard Junior Beam, Indian Standard Lightweight Beam, Indian Standard Medium Weight Beam, Indian Standard Wide Flange Beam, Indian Standard Heavyweight Beam. See, this is the how it is designated: ISMB 500 at 0.85 kN per meter cube, means this is the type of the section ISMB. This is 500 indicates overall depth of the sections, and 0.852 it indicates its running meter weight. Means if you take ISMB 500 of 1 meter length, that for that 1 meter length its weight is 0.85 kilonewton. This is the examples of applications of use of I sections in frame industry in frame steel structures. Similarly, there is the channel sections. That's where ISLC, ISMC, ISLC, ISSC, Indian Standard Special Sections. Okay, so ISMC means Indian Standard Medium Weight Channel Section. 300 means its overall depth is 300, and 0.35 is running meter weight. This is the applications of channel sections in steel structure. Now, roll steel angle. There are for angle there are two classifications. One is equal angle section, another is unequal angle sections. So ISA 150 by 150 by 12, so 150 by 150 by 12. So 150 is outstand weight, 150 is connected leg, and 12 is thickness unequal. Longer leg, that is H, is 150, shorter leg B is 115, and thickness is 12. This is the applications of angle sections in transmission tower. Then similarly T section and tubes and plates and round sections. Then choice of sections. The choice depends upon the requirements and designer choice. Okay, so this choice we are going to discuss in when we are going to solve the actual design problems. This is the figure showing the components of industrial buildings. See how the industrial buildings look like. So we have to design. This is the main aim of this course, structural design 1. This is the truss, purlins, sheets, either GI sheets or asbestos sheets. Asbestos or AC sheets has been obsolete nowadays because it is going to be brittle material. It is going to fail or crack. Okay, so GI sheet, color coated GI sheet nowadays are very popular. Then side sheetings, side girts, column and base plates. Okay. Then loads on the structure. This is very important because when we are going to design any structures, we must have to determine that how many number which type of loadings are acting on the structures. Okay, so dead load first is the DL means dead load. Dead load is the self weight of the structures, and it can be determined from IS 875 part 1 1987. Means in 875 in this code the material densities has been given, and material density multiplied by cross sectional area we will get the running meter weight. In live load, LL is live load, changes from time to time, persons and furnitures, etc., which is given in the IS 875 part 2 1987. And third is the wind load. Wind load is given in IS 875 part 3, which is revised in 2015. Old one is 87, now new one is the 2015 code. Accidental load IS 875 part 5 1987. Then earthquake load, EL is earthquake load, which is given the code is reference code is IS 1893 2016. Now design philosophy. Okay, so before going to the actual start of the design, we must have you must know the different methods available for the designs. Okay, so there are various methods. So first method is the working stress method. Now see what working stress method says. On the stress at which material starts to yield is taken as the permissible stress of the section. All sections are designed not to exceed the permissible stress. Therefore, permissible stress is equal to yield stress divided by factor of safety. Okay. Now, since steel can resist the load after the yield points, means after yielding point, our material have a lot of reserve strengths. So, following this principle results in bulky and uneconomical sections. Means we are not utilizing the full strength of the material, so that's why it results in the slightly bulky sections. Okay, now next method is ultimate load method, or it is also called as the plastic design methods. The details of this method is given in SP 6 part 6 special publication 6 part 6. Okay, the SP6 having lot of parts, and its part 6 is entirely devoted for the plastic design. Okay, so you must read this. Permissible load is the load when all the fibers in the steel yielded. This method does not ensure serviceability. Now see the more elaborate discussions of working stress methods. The linear elastic allowable or working stress design. See, the working stress method is also called as a ASD, that is also called allowable stress design, developed in 19th century, is based on first yield as a design criteria, wherein reaching the yield stress in steel was generally considered to be the one set of the failure, as it represents the point when actual behavior deviates from the analysis results. It is ensured that the stress developed under service or working load do not exceed the allowable stress obtained by yield stress by a factor of safety. These restrictions on stress precluded the existence of non-linearity and buckling effects. Okay, the factor of safety represents a margin for uncertainties in the strength and growth. The value of factor of safety in most of the cases is taken as 1.67. See, whatever we have discussed, it is explained with the help of stress strain curve. This is the stress strain curve for our mild steel. Stress is on y-axis, strain is on x-axis. Now we are getting the such type of curves. Initial part is linear up to proportional limit, then it yields. Okay, so this stress corresponding to yielding is yield stress, and the stress corresponding to U is ultimate stress. And working stress for design of tension member as per given by the old code, that is a 1984 code. See, before 2007 we are using the IS 800 1984. Okay, so 84 code was based on working stress method of design. So working stress method for tension member sigma 80, stress in axial tension is 0.6 Fy. Okay, so for 250 it comes out to be 150 MPa. So here is our yield stress, means material is going to fail by yielding at this point, but we are considering the working stress here. 60% of that means far below the yield and ultimate stress. Okay, so factor of safety is equal to yield divided by yield stress divided by working stress, it is 1 by 0.6, so it is 1.67. Now next, so this is the reason why working stress method has been obsolete, outdated. So now the people thinking about the limit state designs. Now whatever designs we are going to perform in this course of SD1 is all based on limit state designs. And for the limit state design, the IS code is IS 800 2007. Okay, not 84. 84 code based one for working stress method. Now 2007 is completely based on limit state theory. So limit states are the various conditions in which a structure would be considered to have failed to fulfill the purpose for which it was built. Ultimate limit states are those catastrophic states which requires a larger reliability in order to reduce the probability of its occurrence to a very low level. Serviceability limit states refers to this on acceptable performance of the structures. Okay, so there are limit state of strength and limit state of serviceability. So general principles of limit state design is structure to be designed for limit state at which they would become unfit for their intended purpose by choosing appropriate partial safety factor based on probabilistic methods. The two partial safety factor has been applied. One is applied for the loading, that is gamma F, and other is applied for the material strain, gamma M shall be applied. Okay, now partial safety factor for load, that is gamma F, which is given in table 4 of IS 800 2007, and partial safety factor for material gamma M is given in table 5 of the IS code. Okay, you refer the code. These are the limit states of strength and serviceability. For strength, yield and buckling, stability against overturning and sway, fracture due to fatigue, brittle fracture. The serviceability limit states are deflection, vibration, repairable damage due to fatigue, corrosion, fire. These are some basic difference. Few points I have mentioned here to discuss the basic difference of working stress and limit state methods. Okay, so first point, allowable stress design or working stress method consider first yield as a design criteria and allowable stresses as the upper limit of strength in cross section of single members. Limit state design consider the functional limit of strength, stability and serviceability of both single structural member and structure as a whole. Second, use of allowable stresses precludes the existence of non-linearity and buckling effects, as the yielding or buckling cannot occur means buckling and yielding is not occur because we are not going after yieldings in working stress method. But in case of limit state method, post buckling and post yielding play an important role in estimating the capacity of structural member at limit states. Okay, so we are using the nonlinear behavior of the material in limit state methods. That is the basic difference. From stress strain curve, we can easily understand the basic difference between working stress method and limit state methods. It does not consider the redistribution of stresses and as it occurs after yielding starts, because redistribution occurs after yielding and we are not going after yielding, so redistribution does not come into picture in case of WSM, but it considers the redistributions of stresses in statically indeterminate structures. Point number 4, due to greater factor of safety, the allowable stress is a fraction of yield strength. That is, allowable stress are significantly less than Fy. Much smaller material safety factor gamma m's are used for yield and ultimate stresses. The method is based on elastic analysis of structures under working load. In case of limit state, the working loads are factored, that is increased as per the partial safety factor gamma f, corresponding to causing limit state of strength. Okay, so these are the basic few points. There may be a possibility that in the examination that 4 marks theory questions appear on when write the difference between working stress and limit state method. So you have to mention these 4 to 5 points. Okay, so this is about the basic theoretical background of various design methods. Okay, now in next video lectures, I am going to discuss the basic concept of design of connections, simple bolted connections and welded connections. Okay, because before going to tension member, we must have the basic knowledge of design of connections. Okay, so first we are going to, in next video I am going to discuss the design of connections, and after that we are going to start the design of tension members. Okay, thank you.